11-1. Again, make sure you have your IDs on, please. 11-1. Sequences and series. You did this in Algebra 1 and Algebra 2, so today I'm not really teaching you all that much that is different, except for our very last thing. Alright, so a sequence is a function a function whose domain values are non-negative integers. What do I mean by non-negative integers?
Positive whole numbers?
Positive is definitely some of the non-negative, yes, but we're missing a very important one. 0, right? 0 is neither positive nor negative. So when I say non-negative, that includes 0 in all of our positive numbers. Okay, so your input's always going to be 0, 1, 2, 3, 4, 5, so on and so forth. Okay? In short, a sequence is just a list of numbers. At the end of the day, a sequence is just a list of numbers. So we're going to have like infinite sequences, where infinite meaning it doesn't end. Can anybody think of a list of numbers that doesn't end?
Pi.
Pi is a number that is infinitely many digits. But think of like a list of numbers.
Prime numbers.
Prime numbers. 1, 2, 3, 5, 7, 11, 13, 17.
19.
Okay, 19, 23. Okay.
27.
Those are going to go on forever. 27 is not prime. Careful.
Hold on.
3.
29 is though. Okay. But what is another example of an infinite sequence? Odd numbers. 1, 3, 5, 7, ... Even numbers. 2, 4, 6, 8, ... Multiples of 4. Multiples of 10s, right? Those are going to go on forever. Finite sequences are ones that end. If infinite goes on forever, finite ends. So, for instance,
Is that spelled like infinite but without
minus the n. Yeah. Finite. Yes. So we say finite. Like the numbers on basketball jerseys, right? If you were to line up all the basketball jerseys, you might have like 1, 2, 5, 7, 8, 13, 14, so on and so forth. But there are a finite number of jerseys for our team. Okay, or the ages in here, right? How many of you are 15? Okay, well, didn't think so. 16. Okay, 17. 18. 19. 20. 33. Okay, whoa, hey! Pairs. Okay. Yes. Okay, my daughter turns 6 tomorrow and I'm not doing okay. Like I've been I haven't been crying. My eyes have been sweaty. It's like I've been cutting onions. I think it is the allergies, yeah. It just happens when, yeah.
It's supposed to be really bad on you.
Right, yeah, okay. Tomorrow, right, I know. Thank you. Okay, good. They're tears of joy because I'm so happy that she's turning 6. Okay. We got her hair cut yesterday. That's what she wanted for her birthday. That's all she asked for. So, this is after a full day of playing, so that's why her hair looks kind of crazy. But here, okay, so like here's the back of it, right? It's in a little braid. And she's like, I want it all cut off. And I'm like, what? So that's like all of it on the ground. And then that's her.
Oh, she looks like you now.
She doesn't look like my husband or me. I really think that she was switched, but we got the cuter of the kids, probably. I mean, Let's be real. Genetic impossibility here. Whatever. So, this is my dog. Look at that face. Ugh. Buster Brown, look at that face. He's so cute. Oh, so cute. Okay, but then this is her this morning. Of my dog? Yes, I did. Okay, so that's what she wanted for her birthday. So we did that last night. Okay, anyway, sorry to digress. She just wanted her haircut. I mean, she's obviously getting other things. She gets one gift in the morning. Like, she always gets a new outfit before, to wear throughout the day. So she'll get her outfit in the morning, but this year I bought her 2, so she gets to choose. And then she'll get one more, she'll get our other presents tomorrow night, and then her birthday party's on Saturday, and she'll get everybody else's gifts. So, all right. So, what is an infinite series?
A series that goes on forever?
It's going to go on forever. What's a finite series?
It ends.
It ends. Okay. There are 2 types of sequences that you've talked about in the past. You talked about arithmetic sequences. What does arithmetic kind of sound like? Arithmetic, adding and subtracting, right? If you're good at arithmetic, that typically means you're good at adding or subtracting numbers. So arithmetic sequences have a common difference. Bye. No, thank you. Okay, they have a common difference. So this might be like 1, 3, 5, 7, ... Right? Common difference. What's a difference?
Subtraction.
Subtracting. So it's 7 minus 5.
2.
And 5 minus 3. And 3 minus 1. If we were to subtract the next one from the previous, you should always get the same thing if it's an arithmetic sequence. So this just means you're adding exactly the same thing or you're subtracting the same thing to get to the next term.
What if it was like multiplication?
Not arithmetic. You have to add or subtract if it's called arithmetic. If you're multiplying and stuff, it's called a geometric sequence. Okay, and these have a common ratio. What's a ratio?
Like 1 to 3 or something.
1 to 3. Okay, but what do we typically say that as?
Fraction?
A fraction. Right? A ratio is just a fraction.
Like 1/3 longer.
Like 1 to 3 can be expressed as 1 over 3, right? Okay, so these right here, a fraction is either multiplying or dividing, okay? So an example of this might be like 3, 6, 12, 24, ... How am I getting from this number to the next number each time?
Something like 2.
I'm multiplying by 2. It could also go the same way. I could do 24, 12, 6, 3, and I'm halving each time. I'm multiplying by a half or dividing by 2. Okay?
Can it be negatives too?
Can be negatives. Can be negatives. Okay? So that's just a little bit of the background vocab to get you started. Example 1. Find the first 4 terms. So example A sub n, a subscript of n, a sub n, is equal to 3n minus 2. And we want to find the first 4 terms. All right, well, let's find a sub 1, meaning the first term. So what did I replace n with?
1.
A 1. Well, in the actual equation, replace n with a 1. 3 times, it's the first term, minus 2. What is a sub 1?
1.
1, right? 3 times 1 is 3. Minus 2 gives you a 1. So there's my first term. 1, comma. Let's find a sub 2. 3 times 2 minus 2. What is that? 4, right? 3 times 2 is 6, minus 2 is 4. And notice I'm listing my numbers. That is what my final answer is going to look like. A sub 3, well, that's going to be 3 times 3 minus 2, which is 7. And then finally, a sub 4 is equal to 3 times 4 minus 2 equals? Yes! Good. So this right here is what your answer would actually look like. Those are the first 4 terms. And then you can always go back and double check. What am I having to do to each term to get to the next one? Add 3. You're changing by your slope 3. Okay?
Can we do another one?
I would love to. You're going to love this one.
No, never mind.
What's wrong?
I just don't want to do it anymore.
A sub n is equal to negative 1 to the nth power over
Okay, never mind.
2n minus 1.
You can do this one, please.
Oh, I can handle this one.
The spot, right?
Okay, thank you.
It's still not.
Now, you can definitely do this by hand. You should be able to do this one by hand, junior and senior level pre-cal kids. But honestly, what I would do when I were checking this is I would put this into my calculator. Right? I would put that function into y equals and I'd go to my table. So if you want to follow along, I would go to y equals. Again, make sure that your calculator is reset back to function mode. So if it's still in polar coordinates, 2nd plus 7, 1, 2. And I'm going to do alpha y equals 1, parenthesis, negative 1, parenthesis, to the, and we can't use n's here, we're going to have to use x's, over 2x minus 1. Yeah? And so then I'm just going to go to my table and it's going to tell me my first 4 terms. Look at that. Oh, yeah. So what is my first term? The one across from 1. So negative 1. What is my second term? 1 over 3. What is my third term? And what is my fourth term? Miss Cleveland, I love this. Just go ahead and give me the quiz now.
Yes.
Yes.
Let's do it.
Do it.
I'm
Go
ready.
ahead.
No catch.
All right, no more. We're done.
No, on this part, no catch. That's as easy as it is.
On this part.
Uh-huh.
There's a catch later.
We've got 2 or 3 more parts.
No.
Okay. That's pretty easy, right? You're just plugging the value in and you're finding however many terms I tell you. I could ask for the first 3 terms. I could ask for the first 10 terms. I would do it the same way. Okay? Now, let's switch gears a tad. And let's talk about factorial. Does anybody remember what factorial is?
Can be fact.
It looks like this. Can anybody explain what factorial is? And yes, that is an exclamation point. And no, I'm not joking with you. It's the most excited math function. N! But we call it n factorial. Did you like that?
I got no. It's reminding me of something else.
Oh, okay. Thank you. All right, so what this means to do is take the number and then multiply it by the number 1 less, and then multiply it by the number 1 less. So write this, and you're going to be like, I don't understand. Just write it, and then we'll do an example, and it'll make perfect sense, I hope. So n times n minus 1 times n minus 2 times n minus 3 times ... times 1. Just write it, and don't complain. No, don't grumble. If you were perfectly silent, that would even be better. No. I would write it exactly how I wrote it, pumpkins. I would write it exactly how I wrote it, pumpkins. Now, what do these dots right here mean? Multiplication.
Keep going.
What do these ellipses mean? It keeps going. So we're just multiplying and multiplying and multiplying until we subtract 1 so many times that we're literally just left with a 1. I told you, just pause, write it down, and it'll make more sense in a moment. Example dose. Evaluate. 5 factorial. What is 5 factorial? Well, let's follow this template. What is n in this case? 5. What is 5 minus 1?
4.
What is 5 minus 2?
3.
What is 5 minus 3?
2.
What is 5 minus 4, right? Because that's what would come next. Oh, look, I'm at 1. I stop when I get to 1. Right? I've subtracted 1 so many times that I'm at 1. I stop. What is 5 times 4 times 3 times 2 times 1? What's 5 times 4?
20,
Times 3
60,
times 2?
120.
120. Oh, Miss Cleveland, this was fun. 5! Right? But you're multiplying them together along the way. Right? In this one, I wanted you to find 5!
Whoa, what?
Well, it was an excited 5.
Hmm.
5 factorial. Okay, here's another one. This one's going to be really fun. I give you one just to like dip your toe in the water and you're like, this is easy. And then I give you a second one and you're like, psh, psh, and you're like, ah! But then you realize it's okay. 8 factorial over 2 factorial times 6 factorial.
Oh.
You're fine!
What is that?
Suck it up, buttercups!
It's the students that know how to count backwards.
too much excitement.
8! 2, 6! Right? Okay. How do I write 8 factorial? Well, 8 times 7 times 6 times 5 times 4 times 3, do it, times 2 times 1.
That is so many numbers.
You're fine.
No, I'm not.
You just told me at the beginning, you're fine. And I was like, okay. So, Savannah, you're fine.
Leland, hush.
Do not look at me in that tone of voice, girl.
Why are you doing that?
Okay.
Why did you do
So, what is 2 factorial?
no,
2 times 1.
2 times 1. And you just put it somewhere over there. Put it on the green folder so it doesn't get lost. What is 6 factorial?
6 times 5 times 4 times 3 times 2.
You could say that in an excited fashion. This is an exclamation point, by the
Oh,
way.
you're right.
Okay. Jacob, you're fine too. Gosh, everybody.
What?
Okay, so really quickly, look at this excitement that's about to happen. Does anybody see what's about to happen?
Yes, we're gonna divide it.
Look, 6 times 5 times 4 times 3 times 2, 1. 6, 5, 4, 3, 2, 1.
you crossing me out?
Oh my god.
Orange.
Wait, what? Oh, yeah. Let's
Orange. Okay, can I cancel the 8 anywhere down here? Or the 7? No. What is, without using your calculator, pre-cal, 8 times 7?
Yeah.
What's 2 times 1? Nailed it. What's 56 divided by 2 without using your calculator?
20 something.
You did use your calculator.
I've already done this.
Oh no.
20.
Steven, how do we do that without our calculator?
How have you already done this?
It already was already done.
What number is divisible by 2 and close to 56?
60.
Wait, what did you just say?
60. Okay. What is 60 divided by 2?
30.
30. And then how many multiples of 2 would we have to go down? 2. 30 minus 2 is 28.
True.
Right? Like you could get there.
Wham.
Swag.
This one is all by yourself. 2, 6, 3,
That's enough.
5. I'm going to add another one if Savannah keeps dissenting.
Wait, what?
2 factorial times 6 factorial over 3 factorial, 5 factorial. So that's not as exciting. By the way, I don't know another mathematician that says 2! That's a Cleveland original. Hashtag Cleve's original.
Ah.
Are you in pain?
Yes.
I messed
Joke
up.
made me say.
Kyle, don't hurt yourself by, writing this one down or anything. Thank you.
It is written down.
Well, do it.
Oh.
Roasted.
I apologize for adding you.
And it's gone.
Wait,
What?
now I'm confused, Cleveland.
I'm not. Easy money.
It should be 6/3, right?
Oh, wait.
Or
Spoiler
Or 2.
alert.
12.
you should get 2.
Cancel these two.
Yeah. Wait, hold on. Something's wrong.
Two.
It's 2. It's 6/3, which is 2.
You should get 2.
Yeah, 6
Yes,
over 3.
yes. Perfect. You should get 2. You should get 2. The perfect work would be 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. This is so exciting. Cancel city. Cancel city. I just have a 6 and a 3 left. 6 over 3 is 2.
Would there ever be like a 56?
Could. Like this one. Like this one.
Thanks, Nina. Thanks.
Oh, jeez.
That was not Nina's fault. Look right here. In my prepared notes, I had one ready. Don't you worry. So I could put any value I wanted to in here. So sometimes solving it in general so that you know a whole family of functions will be really useful. N minus 1. That wasn't loud. It was still excited.
Aggressive. That's what it is.
N! Okay, here we go. How would I write n factorial? Well, n times, that was aggressive, times what?
Exclamation point.
No, n factorial is n times n minus 1 times
Minus 2.
times
Minus 3.
times, well, until we get to 1, however long that lasts, right? It could be n minus 56, n minus 57, I don't know, until we get to 1. Over n minus 1 factorial. What do I start with for n minus 1 factorial? N minus 1. And then,
N minus 2.
boom,
N minus 3.
until we get to 1. What's going to happen?
Cross them out.
It's just n. So, wait, Miss Cleveland, what does that mean? So, like an actual example, we could, let's see here. Tiana, what is your favorite small number less than 10? 2. Aw. Okay. Right? 2 factorial over 1 factorial. 2 factorial is 2 times 1. 1 factorial is just 1. So those 1s are going to cancel and you're just left with 2. You're just whatever n was. Let's do another one. Lucas, what's your favorite number under 10?
-4.
Aw, 4. Okay, let's do 4. And then n minus 1 factorial, so the number on the bottom would be 3 factorial. So this would be 4 times 3 times 2 times 1 over 3 times 2 times 1. Well, what's always, oh, y'all can't see this. It would just be 4 because these are always going to cancel with the bottom, and you're just left with your first number. Okay, so yeah, I could give you one that was like 56 factorial over 55 factorial. It's still just 56. Okay? But, I mean, let's just figure out how to put these into the calculator. Good kids are going to write down these steps because mean teachers won't tell you again. And I fall into that category. So, write down the steps. Write down the steps. Math, left arrow, 4. To get to factorial in your calculator, math, left arrow, 4. So let's enter in our original A. So if I were going to enter in A, everybody hit 5. Math, left arrow, 4. And you should see 5, exclamation point, enter, 120. Let's enter in B. So we need a fraction, alpha y equals 1. 8 factorial over 2 factorial. And you don't need to put anything in between there. You can immediately go into 6 factorial. 28. Yeah? I want for you to enter in C. What should you get on C? 2. So enter that in and prove to yourself that you know how to enter it into the calculator. If you get 2, you're doing good. Y'all good? You cannot enter things like D into the calculator. Why? There's no number. It's a variable. Okay? You will get it wrong almost every time if you do D in your calculator. That's one that you actually have to mathematically work out. Okay? All right, moving on. It's not defined what it's equivalent to. I mean, you could put it into y equals, but it's not going to tell you what you want to know, I don't think. You'll have to really know what you're looking at to get there. All right, so a series is a lot like this sequence, but instead of just listing the terms, you add terms together. So rather than just listing them 1, 2, 3, 4, you would do 1 plus 2 plus 3 plus 4, and you're adding them together all the time. Okay? So an infinite series would be like 1 plus 2 plus 3 plus 4 plus ... until we get to infinity. Okay? A finite series would be like 1 plus 2 plus 3. Right? You have a set term or a set number that you're adding together. Now this is really fun. You're going to love this. So I'm just going to show you it and let you copy it down. Do not complain. Just copy it down and then I will explain. Oh, did you hear that? Huh?
Oh my God.
I literally am about to quit my job. I'm about to take your calculators away from your quiz.
What is that?
Just copy it down. It's a sigma. It's a Greek letter sigma. Copy it!
How do you even make that?
Yeah, I don't know. Can we have an art class real quick?
It's like a fancy E.
It's so
Oh gosh, I screwed it
up, straight line, into the middle, out, straight line.
That does not look the same.
Looks a lot better than whatever you were drawing. Oh, I'm joking. She's not.
She's dead serious.
I think that was some serious talk there. Well, too bad. I became a teacher to torture kids. I'm not going anywhere anytime soon.
Do you have to copy like?
You have to copy everything you see, Lucas. Hop to it.
In terms of a
Hop to it. And go right itself. Let's go, pumpkins. Nope. Kyle, what's happening? That was the weirdest yawn I've ever seen in my life. Okay.
Yeah. Cleveland, I think we call it.
I don't think I'm giving you that option. What?
I learned this later, earlier in the year. I worked on really good on my academic catalog.
Well, sorry about your bad luck. Next time you'll do good.
Oopsie
I'll
doopsie.
do good now because I know.
What is AI?
AI is just some formula. AI is going to be some formula.
It's like artificial intelligence.
Okay, so this Greek letter sigma just means that's how mathematicians write a whole sentence. Rather than saying, I want you to add up all the values from 1 to n with using this formula, which would take like a sentence or two to do, we just can contain it all in this one symbol. Okay? This I is the index of summation, or basically it's the variable that your rule uses. So this variable right here, I, should match the variable that's being used in the equation. This is where you start, and then you go up every single number until you get to wherever n is. So let's say the n is 3. I would have to do a sub 1, a sub 2, and then I stop at a sub 3. Okay? So you do every number from your lower limit to your upper limit. Yeah? I see most pencils done writing. So let's actually get into an example. Example 3. Find each sum. What does sum mean?
Addition.
Yeah, you're going to tell me what it is when you add them all up. So A, let's find the sum from n is 3 to 6 of 1 plus n squared. Okay, so that's what a problem is going to look like. Find the sum from 3 to 6 of 1 plus n squared. Okay, what? Let's go through this. Alright, so if n is 3, you don't have to write it like this, but I'm just going to organize it for you. Let's find a sub 3. Okay? So what would I have to do to this equation for a sub 3? 1 plus 3 squared. Good, everyone. Okay, right? Good. Plus, what would be the next number? 4. So let's find a sub 4. 1 plus 4 squared. Have I gotten to 6 yet? No, so keep going. Here's our a sub 5. 1 plus 5 squared. Have I gotten to 6 yet? Nope, keep going. A sub 6 is 1 plus 6 squared. Ooh, look, I've gotten to 6. I have to stop now. Do y'all understand how I generated that? Well, what is 1 plus 3 squared? 10. Plus, what is 1 plus 4 squared?
17.
What is 1 plus 5 squared?
26.
And 1 plus 6 squared?
37.
37. Now add all of those together.
90.
I know that you did this all in advance. Give some people some time.
90.
Y'all better hope y'all know what y'all are doing. 90. It is 90. Okay. Now would you like to learn how to do this in the calculator? Good. Kids are going to write this down because mean teachers won't tell you again. Math 0. To enter this into the calculator, math 0. So once you write that down, go hit math 0. Boom. Right? Okay. So this is why I made a big deal about you understanding what every piece meant. Okay. In your calculator, we're just going to use, just get over it. We're just going to use x. So that first box is whatever variable you're using. So enter in x. What is our lower limit of summation? 3. Now hit the up arrow and that'll take you to your upper limit. What's my upper limit? 6. Right arrow. Now I'll enter in the equation, but again, we're going to use x's. So 1 plus x squared. Boom. Okay. If you did not get 90, ask a neighbor or ask me so that I can fix it for you. Yes?
Thought of that, like, equation, like, doesn't that blow your mind? Like, someone just thought of that and made it. That blows.
That's pretty cool, huh?
Yeah.
Maverick? You would have to get everything plugged in correctly. It depends on how much y'all complain in the future if y'all get a calculator or not, so I'd know how to do it without it. Okay?
You guys better shut up.
That's the spirit. Alright, B. I want you to try this one. You can do this in your calculator, but I want to make sure that you know how to do it. The sum from 0 to 5 of 1 over n factorial.
What?
And I think you get like 163 over 60, if I remember from last class.
Not divide by 0.
You're not trying to divide by 0.
That's what I didn't want to divide by 0.
163 over 60.
What do I do?
How do you do that?
Math left 4.
I didn't do that.
And if you did this correctly, your correct answer in your calculator should be 163 over 60. If you do not get that, ask a neighbor or raise your hand so I can come by and help you. Good?